My next topic is about thermochemistry. Thermochemistry is the study of energy changes accompanying chemical and physical reactions. What causes the energy changes in chemical reaction? When a chemical reaction occurs, bonds in the reactants break, while new bonds form in the product. For bonds to break, energy must be absorbed. When new bonds form, energy is released. The energy that is needed to break a bond is called the bond energy or bond dissociation energy. Bond energies are measured in units of kilojoules per mole. Bond energy is measure of bond strength in a chemical bond. It is the amount of energy that is needed to break the chemical bond between two atoms. In some reactions, the energy that must be absorbed to break the bonds in the reactants is less than energy that is released when the new bonds of the products are formed. This means that in the overall reaction, energy is released as either heat or light. The type of reaction is called an exothermic reaction. An exothermic reaction is one that releases energy in the form of heat or light. Another way of describing an exothermic reaction is that is one in which the energy of the products is less than the energy of the reactants, because energy has been released during the reaction. In other reactions, the energy that must be absorbed to break the bonds in the reactants is more than the energy that is released when the new bond in the products are formed. This means that in the overall reaction, energy must be absorbed from the surroundings. This type of reaction is known as endothermic reaction. An endothermic reaction is one that absorbs energy in the form of heat or light. Another way of describing an endothermic reaction is that is one in which energy of the product is greater than the energy of the reactants, because energy has been absorbed during the reaction. During the chemical reaction, the bonds between atoms may break, reform, or both either absorb or release energy. The heat absorbed or released from the system under constant pressure is known enthalpy. And the change in the enthalpy that results from the chemical reaction is the enthalpy of reaction. The next topic that I'm going to tackle is about the first law of thermodynamics. The first law of thermodynamics is also known as the law of conservation of energy, which states that the energy can neither be created nor destroyed. Energy can only be transferred or changed from one form to another. For example, turning on a light would seem to produce energy. However, it is electrical energy that is converted. The way of expressing the first law of thermodynamics is that any change in the internal energy of a system is given by the sum of the heat of the flows across its boundaries and the work which is done on the system by the surroundings. The way of expressing the first law of thermodynamics is that any change in the internal energy of a system is given by the sum of the heat of the flows across its boundaries and the work which is done on the system by the surroundings. The internal energy of a system tends to increase if energy is added on heat and decrease via work done in the system. The law says that there are two kinds of processes, heat and work, that can lead to change in the internal energy of a system. Since both heat and work can be measured and quantified, this is the same as saying that any change in the energy of a system must result in a corresponding change in the energy of the surroundings outside the system. In other words, the energy cannot be created or destroyed. If heat flows into a system or the surroundings do work on it, the internal energy increases and the sign of a Q and W are positive. Conversely, the heat flows out of the system, or work done by the system will be at the expense of the internal energy, and Q and W will therefore be negative. Here's a sample problem of the first law of thermodynamics. A total of 135 joules of work is done on a gaseous refrigerant as it undergoes compression. If the internal energy of the gas increases by 114 joules during the process, what is the total amount of energy transferred as heat? The heat is equal to negative 135 joules. Note that work is done on the gas, so work has a negative value. The internal energy is equal to 114 joules. Note that internal energy increased during the process, so the change in the internal energy has a positive value. Apply the first law of thermodynamics using the values of energy of a system and work in order to find the value for heat. We rearrange the equation to isolate the unknown. Then calculate. Another topic that I would like to discuss is calorimetry. Calorimetry is the process of measuring the amount of heat released or absorbed during a reaction. By knowing the change in heat, it can be determined whether or not a reaction is exothermic or endothermic. Q is equals to 114 joules plus negative 135 joules. Q is equals to negative 21 joules. The sign for the value of Q is negative. This indicates that energy is transferred as heat from the refrigerant. A calorimeter is an object used for calorimetry, or the process of measuring the heat of chemical reactions or physical changes as well as the heat capacity. Another topic that I would like to discuss is calorimetry. Calorimetry is the process of measuring the amount of heat released or absorbed during a reaction. By knowing the change in heat, it can be determined whether or not a reaction is exothermic or endothermic. A calorimeter is an object used for calorimetry, or the process of measuring the heat of chemical reactions or physical changes as well as the heat capacity. So how is calorimeter work? In order to measure heats of reaction, we often enclose reactants in a calorimeter. Initiate the reaction and measure the temperature difference before and after. The heat capacity of calorimeter is determined by transferring a known amount of heat into it and measuring its temperature increase. What is the basic principle of calorimetry? A principle of calorimetry states that if there is loss of heat in surrounding, the total heat lost by a hot body equals to the total heat gained by a solid body, then the rate of heat loss by temperature of the liquid is directly proportional to the difference in temperature of the surrounding. What is the importance of calorimetry? Calorimetry is an important method of biological analysis. Calorimetry is widely used in chemical reaction and the measuring method of biochemical reactions. There are 5 types of calorimeter. The first one is adiabatic calorimeter, the second one, reaction calorimeter, bomb calorimeter, constant pressure calorimeter, and differential scanning calorimeters. The equation for calorimetry is Q is equals to mc delta T, where Q is the symbol for heat transfer, m is the mass of the substance, and delta T is the change of temperature. C stands for specific heat and depends on the material and phase. The specific heat is the amount of heat necessary to change the temperature of 1 kilogram of mass by 1 degree Celsius. Here's a sample problem of how much energy is required to heat 80 grams of water from 26 degrees Celsius to 48 degrees Celsius. The specific heat capacity of water is just 4.184 joules per gram. The formula is Q is equal to mc delta T. Substitute the value in the formula. 80 grams is equal to 80 grams times 4.184 joules per grams times the change in temperature in 22 degrees Celsius, which is the difference of 48 degrees Celsius and 26 degrees Celsius. The answer is 7.363.8 joules. The formula is Q is equal to mc delta T. Substitute the value in the formula. 80 grams is equal to 80 grams times 4.184 joules per grams times the change in temperature in 22 degrees Celsius, which is the difference of 48 degrees Celsius and 26 degrees Celsius. The answer is 7.363.8 joules.